Okay, we've talked about frequency of compounding, and I hope I've illustrated that it matters. So the next quite simple concept is the concept of the effective annual rate. If somebody tells you that they're paying you 5% per annum, compounded annually, and somebody else is saying, hey, they're paying you 4.5% per annum, compounded monthly. Actually, let's make it more interesting. 4.8% compounded monthly. Which of those is higher? How can you compare? Well, you can compare by turning them into an effective annual rate. Remember that if it's compounded anything but annually, the 4.8% per annum is just terminological. It's not a real rate. The real rate, if you're compounding annually, is not 4.8% per annum. Okay. So we've already got the 5% as an annual rate. So we don't need to do anything with that. But in order to compare that against the 4.8%, we need to work out what that 4.8% actually means. Okay, so remember what we did when we looked at frequency of compounding. We basically said, okay, if it's compounded 2 times a year, we divide the 4.8 by 2. If it's 4 times a year, we divide it by 4. If it's monthly, we're dividing it by 12. So the monthly rate is going to be 4.8%, 0.048, that's a percentage, divided by 12. Let's turn that into a percentage. Let's put in a few decimal points there. Okay, so that's 0.4%. Now, I'm wondering if I should illustrate this with a number. Look, it's probably easier if I demonstrate this with one of those tables we did before. So let's put opening balance. Let's put 12 months. Okay. Interest and closing balance. And look, if we put $100 up front, we can see exactly what the percentage rate is at the end because we just divided by the original 100. Okay, so the interest is going to be 0.4% times the opening balance. That's 40 cents. Closing balance is the sum of these two, and the opening balance next period is the closing balance from the first period. Okay, let's just tidy this up and make it, let's just make it down to the closest cent. Actually, let's be a bit more precise. Let's make it down to hundredths of cents. Let's copy it down. So what do we end up with at the end of 12 months? We've got $104.90.7. Okay, since it's 0.7, let's get rid of one of the decimal points, one of the decimal positions. So what's our effective interest rate? 4.8% compounded monthly. Well, after a year, it's like I've earned 4.9%, 4.907%. So 4.8% compounded monthly equals 4.907% compounded annually. So which rate is better? It's still the 5%. I didn't work this out in advance, so that's why I made it 4.8, because I figured, hey, who knows? This one might work out bigger. You know what? Let's actually let's see what 4.9 per annum compounded monthly would be. If I put 4.9 there, this would be 0.049 divided by 12. Wow, look, it's all followed through here. So if it was 4.9% per annum compounded monthly, I'd end up with $105, 1.2 cents. So my effective annual rate would be 5.012% compounded annually. Now, it seems that it's got to be pretty close to be better, but that's because I've only done this for a year, right? If I'd done this for a longer time, the difference may actually be substantial in dollar terms, okay? So whenever somebody tells you a rate, if the rates have different compounding periods, you've got to make them equivalent. Either turn them all into monthly or turn them all into annually. How do you actually do this mathematically? How do I turn the 4.9% per annum compounded monthly into an annual rate? What I can do, I can have 1.049, that's your 4.9%, right? Because we're multiplying this by, actually, I should do it better. 1 plus 0.049. Now, each month, we're only applying a 12th of that, but we're doing it 12 times. Okay, so that's the formula. Let's put an equal sign in front of it to see what it gives us. 1.05012, that's exactly what we had here. So take off a 1, let's space that so you know. Take off a 1, just turn it into a percentage, would be appropriate number of decimal points, and that formula will let you compare. So what we're basically doing is we're saying 1 plus the interest rate divided by number of compounding periods to the power of the number of compounding periods per annum. And that will give you the effective annual rate. Okay, so when people quote you interest rates, if they don't tell you the compounding period, you better ask, because it might make a difference.